Hello everyone and welcome to my YouTube channel. My name is Subhashish Mishra and today's topic of discussion is on MinMaxScaler or normalization. So before we start, let's understand what exactly is a normalization and why we need it. So whenever we get a raw data set, then we will be having a lot of features associated with that data set, right? And each and every feature that we have will have a different measure of unit. And whatever the features that we have, there are two different distincting measure of the features. One is the associated value with that data and the measuring unit of that particular data. So as our motive is to scale down the features, because we know why we need to scale down and everything else in the previous videos. If you haven't watched that videos, if you haven't watched why we need feature scaling and all, I'll put that link in the description and also in the I button above so that you can be able to refer and understand that. Okay, so as our main motive is to scale down the features into a single measuring unit, MinMaxScaler will be another one great technique to the normalization of the data. So one of before the MinMaxScaler, we have also published another one video about the standard scaler. If you haven't watched that video, then please go ahead and watch that video also. That is also another one technique for the feature scaling. Okay. So having said that, normalization, what is the difference between standardization and normalization? Let's understand that thing. Standardization is the Z-score. So Z-score means we are finding out the normalized score for the individual data. That means we are scaling down the data into a single measuring unit. So in that case, there won't be any kind of range within which the data set will be there. But in normalization, we will not so in so here in normalization, we will not only be scaling down the feature into a single measuring unit, also we will be having a specific limit within which the feature will be there. Like by default it is 0 to 1, but we can have our own limit as per our requirement. So the formula for the mean max scalar is x normalized is equal to x minus x mean divided by x max minus x mean. So here x normalization is normalized value of x. Once we have normalized the data, whatever the x norm we are getting, that is the normalized value of the specific x unit. Here x is the input data, as we already know. X mean is the minimum value of that x data and x max is the maximum value of that x data. Now let's understand the practical aspect of the normalization. How does mean max scalar works and what is the impact of mean max scalar with the features that we have using the practical application. Okay, so here we have the Google Colab notebook. Let's do the practical coding over here. So as usual, we have again imported the C1 packages. So now let's see what are the data sets available inside C1. So it's c1.get dataset names. So here we can be able to see these are all datasets present, as you have already seen the same thing in standard scalar video as well. So let's again consider the same dataset, that is Titanic. So here we will be using sns.load dataset and we will be loading the Titanic dataset. Once we have that, then let's check the dataset as usual. So dataset.head, this is the dataset. So in the standard scaler, we have used survived, class, and the fair. These are the three features that we have used. So here also we'll be using these three features only. So one important thing before applying this mean max scaler to this dataset is whatever the scaling technique that we are using, like standard scaler or mean max scaler, both of them are being used only in case of the numeric data. If we have categorical data, then these kind of scaling technique won't work in that. Okay, so only the numeric data we have to perform. Now let's select again survived and then class and the fair. So df is equal to, let's modify the df. So here we will be considering survived feature and then we will be also considering class. Okay, so these are the three features we have considered in case of standard scalar. In MinMaxScaler also we'll be considering these three features. Let's update the DF. Now let's check the head of the DF. Okay, this is how it looks like. Now let's check the shape of the DF as usual. What is the shape? So we have 891 rows and 3 columns. Here survived is our output column, that is 0 and 1, and class and fare will be our input features, that is the X variables. Now before we apply MinMaxScaler, as usual we know that we have to split the data into training and testing unit to make the dataset learn properly. So let's import the library for splitting of the data into training and testing. We will also be importing the MinMaxScaler from sklearn.preprocessing. Now before doing the splitting, let's understand what are the X and Y, and let's divide the data into X and Y. So here Y will be the survived one. So we'll be taking survived as the Y value, and for the X we will do df.drop. Now drop of what? The survived column. Drop. Okay, now let's do the splitting into training and testing. We'll split the data into 33% we will be taking as the test data, and rest 67% we will be taking as a training data. So let's initialize the MinMaxScaler. So we will be not providing any range or any parameter inside it, so that it will take whatever the default it has. So once we do that, if we do sc dot, then we will be able to see all the associated methods available with the MinMaxScaler. So here we can be able to see the feature range. What exactly is the feature range for MinMaxScaler? The feature range is 0 and 1. We are taking the exact feature range. We are not being changing anything else from our side. Okay. So we'll be first fitting and also transforming the training data, and as we know we will be doing the same, we will be applying the same transformation with the test data. So we will be fitting, we'll be doing fit transform with the train data and only transform with the test data. Once train data is transformed, we can be able to check the train data. Okay, so as you can see, the minimum value over here is 0 and maximum value is 1. Now let's apply the same transformation to the test data. Now the test data is transformed. Now let's check hex test scaled. Okay. Now as you can see, the same scaling technique that we have applied, the same measures between 0 to 1 has been applied with the test data. So this is all for this video. If you like this video, then please like, subscribe and share with whoever needs. And in the next video, we'll be trying to discuss about the possible correlation techniques available in Python. Until then, stay tuned and enjoy machine learning.